Yesterday, I asked people to give me feedback on what food I should eat next, and the response that I liked the most for this lesson was apples! So I went and got some apples and cut them into quarters or fourths. Have you ever wondered why quarters are called fourths? Maybe it has to do with the Spanish word or the Italian word for four. If you know the Italian or Spanish word for four, let me know in the comments below, and let's see if we can figure out what that has to do with the word quarter. Anyways, so I've cut my apples into quarters or fourths, and the thing that I want to know is, actually, how many whole apples do I have? Because I have a whole bunch of pieces, but if I were to put them together, how many apples would I end up having? Let's see if we can figure that out. Here's my plate of apples, and I guess the way that I can figure out how many apples I have is just to start putting the fourths of apples together, and there's one, and then put this one together, and then there's two. Okay, so I've got two whole apples over here, and then, oh my gosh, this is too difficult. It's hard keeping all these apples together. I wish there was some way I could do this mathematically rather than manually putting all the apple slices together. I wonder how I could do that. What I'm really trying to figure out with my apple question is how many whole apples do I have on my plate, and then how many extra bits do I have left over. So really what I'm trying to do is convert the apples into a mixed fraction. Yesterday we learned how to convert mixed fractions into improper fractions, and today we're trying to do the opposite, convert improper fractions into mixed fractions. Let's start with an easier question. I have some apple slices here that I've divided in half, and the question is, what's the improper fraction for two apples cut in halves? Well, remember that our numerator is going to be how many pieces we have, and then our denominator is going to be how many pieces the apple is cut into. So we have two apples, let's count the pieces. Well, two apples, two pieces each, 4 pieces. So 4 halves. What about 3 apples? That's going to be 3 apples, 2 pieces each, so 6 halves. What about 4 apples? Well, that's 4 apples, 2 pieces each, so 8 halves. Are you seeing a pattern here? I hope so, because the next question I'm going to ask you has no picture. What if you had 10 halves of apples? How many whole apples would that be? Perhaps you can imagine that in your head? Or maybe you knew the pattern that I was pointing out before. If you have 10 apple halves, you know that there are 2 halves in each apple, so the number of whole apples is 5. And what you just did there in your mind when you were thinking about that is division. And that's the secret to all of this, is that fractions are the same as division. In other words, 10 halves is the same as 10 divided by 2. Have I just blown your mind? Well, hold on to your seats because things are going to get even more amazing. As I said, fractions are just miniature division problems, and you can rearrange a fraction into a division problem really easy. 8 halves is the same as 8 divided by 2. And for people who are having a little bit of trouble remembering how to do division, you can use your multiplication facts to remember that division is the opposite of multiplication. Or you can use your skip counting if you're really stuck for a way to do this. How do you use your skip counting? You say that you count by the second number until you get to the first number. And if you're skip counting on your fingers, then you just ask yourself, how many fingers am I showing at the end of all that? So, if I'm doing that for 8 divided by 2, I would say 2, 4, 6, 8. Oh, I'm holding up 4 fingers, so 8 divided by 2 is 4. So that's how you can divide using skip counting. If you have another method, that's fine. The whole idea here is to use division to convert improper fractions into mixed fractions. But before we do that, let's take one step easier. Instead of doing mixed fractions, let's just convert improper fractions into whole numbers. So I've given you some improper fractions that convert perfectly into whole numbers, and all you need to do is use division to figure them out. So press pause, to figure them out, and then press play again to check your answers. Welcome back. Let's check our answers. In the top left corner, the question is, how many whole apples are there in 12 halves of apples? 12 halves. Well, that's just 12 divided by 2. And we know that 12 divided by 2 is 6, because 6 times 2 is 12. So it would be 6 whole apples. What about in the top right corner? 18 halves. Well, 18 halves is the same as 18 divided by 2. And 18 divided by 2 is 9. And we know that because 2 times 9 is 18. So 19 whole apples. Bottom left corner. 15 thirds. 15 thirds of apples? Well, 15 thirds is the same as 15 divided by 3. And 15 divided by 3 is 5. And we know that because 3 times 5 is 15. Finally, bottom right, 20 fourths. Well, 20 fourths is the same as 20 divided by 4. And that's easy. 20 divided by 4 is 5, and we know that because 4 times 5 is 20. The tricky part in all of this is that most improper fractions don't convert perfectly into whole numbers. Most of them convert into mixed fractions, which are going to have a whole amount and a little bit of leftover. And so how do we deal with the leftover bits? Let's use 9 halves as an example. If I have the fraction 9 halves, how can I know how many whole apples there are, and then how many extra apple pieces there are that are not fitting into a whole? What I want to do is to divide 9 apple pieces into sets of 2, and then figure out how many whole apples that makes, and then how many extra slices there are. And the whole apples is going to be our whole number, and then the extra slices are going to be the fraction part of the mixed fraction. Now remember, we're going to be doing division to do this. And as I said before, when you're doing division, one of the ways you can do it is to count by the denominator until you get to the numerator. Let's give it a try. Let's deal with our wholes first, and then deal with our parts. 9 divided by 2. Let's deal with the wholes first. 2, 4, 6, 8. Okay, 8 divided by 2 is easy. 8 divided by 2 is 4. But we still have some leftover pieces. In division, what are our leftover pieces called? That's right, they're called remainders. So we have 4 remainder 1. 9 divided by 2 is 4 remainder 1. What do we do with that information? Well, the 4 becomes our whole amount, so 4 wholes, and the remainder goes into our fraction bit. But what do we put for the denominator? Well, remember what I said about improper fractions and mixed fractions. They have the same denominator. Looking at our improper fraction, we can see the denominator is 2. And we can also see that the apple slices are broken into 2 slices for each whole. So we know the denominator is going to be 2. Let's try another one. 15 fourths. First we need to deal with our whole number, and then we'll deal with our remainder. So we need to count by 4s until we get to 15. We know we won't get there, but we'll get somewhere close. 15 divided by 4. 4, 8, 12. Okay, so 12 pieces. 12 divided by 4 is 3. But we have some remainders. What's the remainder? It's those extra pieces that don't fit into a whole. And you can see there are a remainder of 3. So 15 divided by 4 is 3 remainder 3. How do we write that? We write our whole number as the whole. The remainder goes into the fraction. And what's the denominator? Denominator is 4 because that was the original denominator in our improper fraction. Whew, that was difficult. And now it's going to get even more difficult because I'm going to ask you to do it without pictures. So remember, we're skip counting by the denominator until we get to the numerator, and then the remainder becomes part of the mixed fraction part on the right. I think you can do it. Try your best. Press pause to try it out. Press play to check your answers, and I'll show you how I figured out my answers. Welcome back. Let's give it a go. 14 thirds. Well, 14 thirds is the same as 14 divided by 3. So let's count by 3 till I get to 14. 3, 6, 9, 12. Oh, that's as far as we're going to get. So how many fingers do I have? 4. That's going to be our holes. But 12 isn't 14. There's a little bit left over, right? 12, 13, 14. There's a remainder of 2. So 4 and 2/3. Question on the right, 11/4. So we're going to count by 4 until we get to 11, or as close as we can get. Here we go. 4, 8, and that's as far as we can get because if we do one more, then it'll be 12. So how many fingers? 2. So 2. But 8 is not 11, right? There's a little bit left over between 8 and 11. 8, 9, 10, 11. That's a remainder of 3. So 2 and 3/4. Question in the bottom left. 21/6. 21/6. So we're going to count by 6 till we get to 21. 6, 12, 18. That's as close as we're going to get. How many fingers do we have? 3. But 18 is not 21. There's a bit of a difference between 18 and 21. 18, 19, 20, 21. There's a remainder of 3. So 3 and 3/6. Finally, 27 divided by 5. 27/5 is the same as 27 divided by 5. So let's count by 5s till we get to 27, or as close as we can get. 5, 10, 15, 20, 25. Okay, 25 is as close as we get to 27. I see I have 5 fingers out, so 5, and what's the remainder? Well, 25, 26, 27. Oh, a remainder of 2. So 5 and 2/5. And that's how you convert improper fractions into mixed fractions. Now that I know how to turn mixed fractions into improper fractions, I can just do that with my apples rather than trying to piece them together manually. So first I need to make my improper fraction. I know these apples are divided into quarters or fourths, so the denominator is going to be 4. What about the numerator? Well, I just need to count the apples, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11/4. Okay, now what do? I need to count by 4 until I get to 11, or until I get the closest I can to 11. 4, 8, can't go to 12 because that would be over 11, so I have 2 holes, so the whole number would be 2. But what about the leftovers? For 8, I have a remainder. A remainder of what? 8, 9, 10, 11. A remainder of 3. So I have 2 with a remainder of 3. And what's the denominator going to be? The denominator is going to be 4, because I remember that I've divided all of these apples into fourths, which I also know from the improper fraction. So I have 2 and 3/4 of an apple. Now I know what some of you were thinking. That was pretty difficult. And it was. That's because I just got you doing grade 6 math. Yeah, I sneakily got you some grade 6 math today. So if you had trouble doing this, you're not quite sure how to do it, you're having a little bit of difficulty, don't feel too bad. It is grade 6 math. I wanted to give you a bit of a challenge. And if you don't get it this year, you'll get it next year. In the meantime, I want you to try out page 208 in your Jump Math book, and then complete the online quiz when you're done. And while you're doing that, I need to eat these apple slices before they turn brown.